let's get started. Today, we are going to jump more into TDD, or test-driven development. I just want to remind you, I do have the chat closed because it's very distracting for me. So if you have a question, please just come off mute or raise your hand. That worked really well yesterday as well. So today we want to understand, like, why are we doing this test-driven development? You learned a little bit about testing yesterday. So now we want to talk more about what is TDD and how it's about asking questions and helping us make decisions. We want to understand the role of test-driven development and how it streamlines our problem-solving, design, and architecture process in building code. And we want to talk about the difference between unit and integration tests. So we'll go over vocabulary for that today. The first thing I want to do, though, is a warm-up. And I would love this warm-up to be in an actual physical notebook with a pen if you have that available to you. I know some of you might not. If you don't, that is okay. But it's definitely shown that, like, writing things down in a notebook is more beneficial for learning in the brain than just typing things down. So let's get those creative juices working this morning. In your Slack channel, I just dropped some questions that I would like you to answer in regards to the code right here, this house test code. Thumbs up if you can see this okay. Okay, awesome. At least a couple of you can see it. So, so let's take about 4 to 5 minutes to go through those questions and answer those regarding this house test.
We show the questions again, or the other ones in the Slack?
The questions are in the Slack, your 2006 backend channel.
Hey, Kat.
Yeah.
The code window's a little off the screen. Thank you.
Is that better? Perfect. Thank you. I'm just realizing you can't even see all of it. All right, I know the font is small, but there was one of the tests was hiding. One of the tests was hiding. Oh, man. Okay, about 30 more seconds to finish up your thoughts. All right, so let's come back together here. We're not going to go over those questions, but I just want you to keep your responses in mind as we continue through this. Oops, I did that wrong. As we continue through the lesson, and we'll come back to a lot of those ideas. So actually, I don't know. Okay, so when we're thinking about a new project, as I'm sure you might be experiencing, sometimes it can be really difficult to get started. Testing kind of helps us ask questions and make decisions about what should our code be doing, what task, what piece of our code do we want to get started with or accomplish right off the bat. So this testing compels us to make these difficult decisions early up front. And this could be scary because you're having to make decisions about code you haven't like gotten into yet and haven't gotten dirty yet, and maybe you don't know the full context, and that can be challenging and maybe overwhelming. As you practice that more and more though, you'll start getting into a rhythm about that. But testing serves as kind of a discipline tool to keep you very focused and streamlined on what you're trying to accomplish with the code. So let's talk a little bit about why we even write tests. So let me make this a little bigger. Right, so I'll keep some notes here, and feel free to jot them down in your notebooks as well. But why do we test? So there's a couple of reasons. Anyone have an idea? If you want to just jump off mute and maybe say like, why do you think we test our code? Any thoughts?
To fulfill some features.
To fulfill some features?
Example.
Well, we could definitely write features without tests, right?
Well, but
So
meaning
why
like, for example, say I want the house to be a color and have floor, and then so then I write a test to fulfill that. I want the house to be painted, then I write a test to fulfill that. I write a test and code. Yeah, so the test is like my wish list, and the code is.
I like that.
The wish list. Is that?
Yeah. So that one actually, okay, now that you're saying that, maybe we can answer these questions together, because why we write tests versus why we write tests first can be two totally different things. So I'm going to add that here. So it's like a wish list. I really like that. So the test gives you a wish list. We'll talk about this in a second. Let me push pause on that for a minute. I want to come back to just why we write tests in general. So thank you so much, Nico. Priya, I think you were going to say something about why we write tests.
Yeah, I think it's also because you can like, I don't remember the word for it, but like you can make changes more readily, more easily. I think I remember they taught us some word and I wrote it. I don't know.
Was it refactor?
Yes, that's the word. Thank you.
Yes. And that's perfect. So make changes easily. And so we call this refactor with confidence, right? So if you think, oh my gosh, confidence, I can't type and talk at the same time. So when you think about, you get your code, we go through this process, right? Red to green refactor. So red to green means make it work, and then you can make it pretty or more elegant or a more efficient solution. And that's the refactor piece. So if you already have code that's working, it's doing the thing, and if you have a test for it that tells you it's actually accomplishing the thing, whatever you're trying to do, then when you refactor, you can run your test suite and you'll know it's still working, or my refactor actually broke everything. I should go back a step to where it was working and then continue to refactor. So testing allows us to refactor with confidence because we already have like a benchmark showing us this code works, and we just need to continue to keep it green. Okay, along those same lines, Sorry, was there a question?
No, you finish your thought, and then I just wanted.
I was going to move to the next bullet. So go ahead, Danny.
I was just curious if it would be accurate to say that like rewrite tests kind of create like a roadmap either for ourselves in the future or like developers in the future, just makes it a little bit easier to understand like what it is that we're actually trying to accomplish.
Yeah, exactly. So that's great. So roadmap for future developers. Yep, that's exactly correct. Because just like you were seeing, hopefully with this house class, you know a lot about that house class without even having seen that house class file. So this makes it very explicit to future developers that we expect this class to have a method called floors that returns an integer. And we expect it to have a method or an attribute in this case called color that will return a string representing the color of that house. So that's exactly correct that it is also a roadmap. The other thing similar to making it refactoring with confidence is adding changes or adding new features with confidence. New features with confidence. If you know you have a test suite that works and you have all your code that makes all the tests pass, and now you know your manager comes to you and says, okay, now we need to add these 5 new features and that are kind of built upon the other code that you already have, you'll be able to add those features and run the test suite to see if you adding those features broke any of the existing code base. Okay, so it allows you to build with confidence. Okay, so these are some cases. There's many, many more, but this is what we'll focus on today. And now, why write tests first? Right? This whole idea of TDD, test-driven development, means we want to write our tests, and our tests should drive our development. So it's not that we write code and we see that it works, and then we write tests just to maintain that integrity. We want to actually write the tests first. And this is a lot like what Nico was saying, is it creates like a wish list, right? So if we write a test, say this test, for example, where we know we want attributes and then some methods that'll allow us to access these attributes of floor and color. If this is the test I just wrote, then now I know, okay, I need to go now to my house class and write a method to create so that I have access to floors and color. Now I can think about a million other attributes I might want to have in my house, like maybe how many windows is there, and what is the address, and is it 2-story? Oh, I guess it has floors. What color is the door? So while you're coding, if you don't have a test to guide you, your brain is going to think of all these other things you might need somewhere down the road. Okay, but we only want to code the thing we need right now. So TDD allows us to be very focused in our test writing. So I'm going to put this down here too. Helps us be focused in our code writing. And along with that, only writing the code we need. I'm pretty sure there's an acronym for this. That sounds funny. Okay, I'll leave that for now. But that's the example of this. We don't want to just have code all over the place. We only want to write the code we need. We want to be very focused and intentional about that code. So TDD allows us to do that. The other thing TDD does is allows us to really think about what it is we want from the code. For example, here we wrote this test regarding this method of occupied. And we know we want it to return a Boolean. So I wrote this test first. So now I'm very clear when I go to write this method, does my occupied method take an argument?
No.
You can, no, thank you for participating. It does not. So I know when I write my method, it will not take an argument. And I can see right here, the return value is a Boolean. So I better make sure that the return value of my method is actually a Boolean. Right? So do you see how testing can help us become very clear about what it is we want our method to do in terms of its input and its output?
Yes.
Yeah.
Oh, thank you. Perfect. The other thing TDD might help you do is break down problems. So break down problems. You might have maybe something, a user story or something that says, okay, make make a deck of 52 cards. And you're like, oh, okay, wow, that sounds like a lot of things to do, because you might have to do step 1, then step 2, then step 3 to actually accomplish that. So when we write tests, we're able to break that down a little bit and see, okay, well, if I need to create the whole deck, maybe first I need to find out what suits I have available. So I'll write a test for that. And then I might need to see what are the values of those suits available, and then write a test for that. So it allows us to break down our problem into tiny pieces. That one, though, I think does take some practice. And the more you work on these projects, the more you code in class, you'll get a feel for how TDD allows us to break down problems. Okay, any questions yet? It's just about why we test, why we write tests first.
Kat, could I add one to the bottom?
Yeah.
So
Yes.
just in my experience, if you don't write the test first, they'll never be written. So do it first.
Yes. So it gets done. Right. So there are some shops, like code production shops out there, that they might write the code. I've been a part of one of these teams. It was a very interesting experience, especially coming from TDD at Turing, where they'd write the code and get everything working, and then they would write the test to support the code that they wrote. There's some problems with that, though, right? Because one, then testing becomes a chore to do afterwards, just like you were suggesting, Ryan. And then it might not even get done because you're like, well, the code works, so this testing is not a priority anymore. I want to move on to the next feature or the next piece of code. So writing your test first ensures it gets done, and it just becomes part of your normal process. Okay, so the process we want to follow is write the test for a method, then write that method. Okay, cool. You got it from red to green, it works. Now write the next test for the next method, then go write that method. So that should be your process. And we'll get into the habit of showing you that process more in lessons as we start utilizing tests. Okay.
Yeah, because I feel like if you try to write your code, then you can get like false positives now because you're just trying to amend that, and then it leaves less room for like expansion.
Right. Well, when you write your test second, you're right. You're making your tests and you're trying to get them to pass with the code you have, right? And so it's like your tests are conforming to your code when it should be the other way around. If you've got a strong test that clearly identifies what's the input of the method, what's the output, then you can write your code to match that because you've given it thought in terms of the test. So your code should conform to the test, not the other way around.
Luke had a good example. It's like building a house and then making the blueprints. It doesn't make sense.
Yes, that is beautiful, Luke. I love that. So you don't build your house and then create the blueprint. Recipe for disaster. I really like that analogy. I'm gonna have to remember that. Okay, so let's talk about a couple different kinds of tests that we're gonna use primarily here in Mod 1. So we have, there's more types of tests than this, but this is what we'll cover today and focusing on Mod 1. We've got our unit test and our integration tests. Okay, so think about when you're writing your program, and maybe you've already experienced this with your project you're working on right now, but sometimes you have a lot of smaller methods or helper methods that support a larger method. Or maybe you've got some kind of runner method that calls like 5 different helper methods, right? So each of those helper methods, we want to test those in what's called a unit test. So we're just testing that one little method and its functionality. We're testing it in isolation. Whereas an integration test is if maybe we test that runner method that's relying on a bunch of other little methods or helper methods, and then the integration test makes sure that okay, sorry, I can't talk well today. And that integration test ensures that everything's working together properly. Okay, so the unit test will test each method in isolation, make sure the input's correct, the output's correct. Then that integration test makes sure that everything's working together and playing nice together. Okay, So maybe I'll write a little definition here. So test one method in isolation, the helper methods. And then our integration test, methods that have maybe interdependencies. Okay. In future mods, you'll learn about feature tests and acceptance tests. That relies on some user experience and front end interaction. So we will leave those for now, but just know there's many, many different kinds of testing. But these are the ones we'll focus on in this mod. Okay. Awesome. So let's take a look at some tests and talk about maybe what's not so great about these tests. So let's see, I've got this one first. Is it off the screen or can you see it okay?
No, we can see it. I
Yeah.
can.
Okay, so now this is just an example. Normally this would be the class file and then this would be in its, in its own test file. Okay, but for sake of reading this together, so go ahead, take a minute just to look through this code, and there's some omissions here. And then I'm going to ask you to identify what could be problematic about this test. And I'll call on someone in a minute. Dan, do you have any thoughts maybe that you'd like to share about why this could be problematic?
And just to confirm, you're talking about the setup or the actual test current card?
Not the setup, but this test current card. And if there's questions about this actual, like what the code I have here, please ask that as well. And if you're not sure, that's totally okay. This one's kind of a tough one.
Honestly, I'm not sure.
No problem. Let's phone a friend. We can phone a friend. How about Logan? I don't think I've called on you yet. Oh,
all right. So I was thinking your round.current card probably won't always be the first card in the deck.
Maybe. Let's say that it is, though. It should be that first card in the deck for the current card, because that's the one we'll pull.
I'm not sure then.
That is okay. Corey, I think you raised your hand. Did I read that right?
Yeah, it was one of those things where you do this, but it's okay.
Yeah, you're like, maybe. Okay.
The thing I'm seeing is that the cards variable. I don't see it anywhere else.
Okay, yeah. So that one I didn't want to build a whole cards
Okay.
thing, so I just implied it here. But here's what I want everyone to look at. So remember with this assertion, right? It's expected versus actual. So what we're expecting here, deck.cards.first is, well, here, hold on, sorry, I'm not wording this very well. And then current card is what we're is the actual, right, from taking this deck and calling the method current card. Well, if you look right here, this code is exactly the same as this code, which means this will always result in a positive, right? Because we're calling a method and then just putting the same exact code from that method right here.
So it'll always
be. You see that? That's kind of a vague one, but what this will result in is a positive every single time, no matter what. We want our test to be able to fail, right? So maybe instead, if this was just a simple like card instance, like, okay, if I had like set up all my cards, card 1, card dot new. I'm just going to do this for et cetera, et cetera, et cetera. And then we built our deck out of those cards. We would want to say explicitly here, maybe card 1. Okay, and then maybe we had like, I know I have a lot of missing pieces. I don't want to confuse anybody.
Kat, could you
Right.
use like a insert includes? Or insert include?
Well, you could, but we're looking very specifically for the current card. So we don't want it to be multiple cards. We'd only want it to be one. So the point don't think too much about that. I know this is very similar to like your project, right? So you're probably thinking about that right now, but shift over to just, I want you to think about the assertion. This is saying very specifically, it needs to be this card. So if something is happening here and the deck's not being built correctly, this should result in a different card than card 1. So this test could actually fail. Whereas if this code is exactly the same as the code in the method, that test is not going to ever fail, even if it's not giving us back what we're actually looking for. I don't know.
It's
Does
not
that
a
make
true
sense?
test, right?
Right. It's not a true test. It's not like a robust test. Angela, do you have a question?
Just a comment. So basically, we shouldn't assert, like compare a method to other methods. We should usually compare a method to a return value that we expect from that method.
I would say generally yes, but generally, right? Maybe there are some cases where you would want to hear that. Hold on a second. It's my timer. Okay, so we'll take a palm in just a second. So yeah, generally speaking, you want to be a little more explicit about what this assertion is, about what it is you're expecting. Right? We don't want it to rely on the same code that the method itself is calling. Okay? I think this is maybe a hard one to see, but I just want you to get into the idea of being very explicit with what we're expecting from our tests. Okay, let's take a quick palm 5 minutes, and then we'll come back and look at another example. And then at some point, hopefully, we will have you practice some. So
Can we see?
let's say
Can
9.
we see the notes again? So,
Oh, the notes. Yeah,
then,
I'm sorry.
when you go on break, so I can. Thank you. I appreciate it. Cheers.
Absolutely. Cheers. I like that. Cool. So let's come back at, let's say 9:35.
Thank you, 9:35.
I love that. Thank you, 9:35.
You better say that loud and proud, Arike.
I was mostly laughing because I thought someone said you're welcome. I think
Why do you guys say that?
No, I didn't.
It's in the performance. It just kind of solidifies so that everybody remembers when to come back.
Oh, okay.
Someone from the last mod, she said it was like a music thing when they had music rehearsal. The conductor, I don't know, would say like, okay, be back in 15, and they would all say thank you 15. So I think it just solidifies that you heard what it is. You know, I don't know why I haven't thought about this before. I really need to implement that with my children.
Yeah, it absolutely comes from the performing arts. The biggest one is curtain call in 5, and everyone says thank you 5, so they know, hey, show starting.
Awesome.
Oh, cool.
And this is why we love that everyone comes from a different background, because it makes our experiences so much more rich, right? We get to learn other things. Okay, go take a break.
We just want to sit and talk to you, Kat.
I just want to sit and talk to you too. All right, that was perfect timing. The song ended right when it needed to. All right, we all back? That's a silly question. All right, so let's go ahead and look at another example here. Thumbs up if you can hear me and see my screen okay. Perfect. Okay, so take a minute here to look at this example. Again, this would be its own file. This would be all in the test file. But see if you can identify what the problem with this test might be, or what issues might arise. And why don't I have, once you've looked at it, if you want to raise your hand to take a quick guess at what might be problematic about this one. Ooh, Danny, do you want to go ahead and try?
Well, the first thing that I noticed is it says assert equal to, which would lead me to believe that that's like a count of something, like maybe a count of the numbers or whatever that our calculator needs. But then it's calling on the dot divide, and it's giving two specific numbers as the arguments. So I'm not really sure why we would do a count versus like the actual expected number that comes after the divisible.
Yeah, so I think, this I think is actually okay, because we're calling on that divide method.
Right.
And giving it two numbers and say, like, can you divide 8 divided by 4, which should equal 2. So that part of this is actually okay. Where's my participants list? Let's see, I saw Brett, your hand go up next. Do you wanna, oh, all the hands went away.
Yeah, you scared them.
Brett, I did scare them, I'm sorry. Priya, do you wanna?
That's funny.
I was trying to give someone else an opportunity to talk, sorry.
Oh, that's fine. Then Sean, thank you, Priya, I appreciate that. Sean, do you wanna take a shot at it?
Yeah, I don't know if it's like a nitpicky thing, but should it be like test it can divide? But more importantly, we're setting it equal to 2. Should it be like can we actually do the division num1 divided by num2 so it's more dynamic?
Well, remember that would bring us closer to this, or the problem we had here first, right? If we had num1 divided by num2 here, it would be the same exact code as here. So we'd always get a positive with this assertion. So I think this is okay. Priya, do you want to share?
There's two things I wanted to, like, one was a question. Why is it assert equals the number 2? Why isn't it like capital calculator? I have a question about that.
Yeah, so this method, right, calculator.divide, we can see here, it should return a number, right? Because if we're dividing 2 numbers, we want it to return an integer. So that's what this represents, is the return value that this method will result in. Does that answer your question?
I was more concerned about, okay, the cap calculator would be an assert instance of, okay, that Danny got my question in the chat. And my second question is, if we're doing a test, shouldn't we be testing also where it breaks? So like, if we're doing divide, shouldn't we be seeing what happens when you divide by 0? Shouldn't that be like a, just maybe about that?
Yeah, so that's good. So now you're talking about edge cases, which is, okay, we can see this works for an ideal situation, right? But yeah, what if the denominator is 0? What happens? What happens if we're dividing 7 by 4? Do we want an integer back? Do we want a float? How many decimal places do we want? So this is not a robust test because it does not test any edge cases. It tests this very nice, pretty example of 8 divided by 4, which is a nice round number, right? So yeah, thinking about these edge cases will help you have more robust tests. So we'd want another one here that would give us not a clean division, that would have a remainder. We'd want to divide by 0 to see how does our code act when that happens. So thinking about those edge cases is challenging, but it allows you to think about all the possible errors that could creep up in your code. Okay. All right, cool. So let's do a practice here. And then we'll do, oh, do I want to do that? Let's talk first about command versus query, because I want to make sure I get to this, and then we'll do a quick practice. So command versus query. We have two kinds of methods, generally speaking, a command method and a query method. And knowing what kind of method you're working with will help you in writing your test. So let me pull my notes out. Oh, I'm in my notes. So a query method just wants to give us information about the object. Okay, so for example, let's pull my house test over here. My dot floors is a query method because it's not doing anything other than just giving me back information about my object. My color method is also a query method. It's just giving me information. It's not doing anything. It's not changing anything. It is just, it's like me asking a question and the code giving me an answer, a query. Right? And then the other one, a command method, actually changes something about the object. I also like to say this has side effects. Right? So shout out real quick, what's the method in this house class that would be considered a command method?
Add person.
Yeah, add person. And also paint, right? Because right here we see this is a query method. We're saying, is it occupied? And the code gives us a Boolean, yes or no. So that's a query method. Now add person, right? And if you notice here, we actually don't care about the return value of .add person. We're not testing that return value. What we're testing is that it changed something about our code. See, now .occupied is true. So the add person method is a command method because it changed this occupied attribute about our house. So then we're testing, if you notice in these tests, the two assertions are actually testing that .occupied method. And then we are running a command method and then verifying that it did have a change. It had a side effect. Okay. Same thing here with this paint method. So we initialized our house with the color white, and then we did a command method. We did paint blue, which changes it. And now we're not testing the .paint method directly. What we're testing is its side effect. Did it actually change the color? Okay, so that's something you can think about when writing your test, is if it's just a query method, you'll want to write an assertion for that method directly. But if it's a command method, you'll want to test, run a query method, then execute the command method, and then assert again, test that query method to ensure that the command method actually made the change you expected. Brett, do you have a question? Oh, you're on mute, Brett.
Do you only refer to them as query methods and command methods when you're testing them?
No, you can refer to them like that just in general.
Okay.
And you might hear them called other things like getters and setters, but I like this command versus query idea. Okay. So I think.
Sorry, Kat, you mentioned setters and getters, and those words feel really familiar to me. Which one's for which? For command and query?
What do you think?
Would command be a getter?
So getter would be getting information.
That's a query.
A setter, that's a query.
Got it.
Getter. Right? And then a command is actually changing or setting a value.
Thank you.
Yeah, I know. You're like, you can't just mention something and then drive by. Okay, so an hour goes by so fast. What I want to do is take a look at this interaction pattern with our car here. Keeps going down. So if this is, I want to do a quick practice of what this looks like in terms of looking at an interaction pattern and then creating a test based off of that interaction pattern. Because remember, what a test should do is clarify the input and the output, or the input and the return value. And that's exactly what the interaction pattern is helping you with. Now get into this practice, because come, when you have a job and later in this mod, you're not going to have interaction patterns. Your boss is not going to write that for you. They're just going to say, make a car class, and it needs to tell me about the make and the model. It needs to be able to drive. There's not going to be an interaction pattern, so you'll have to make those decisions. So if we think here, so I have a car test set up already. I'm going to, first, of course, you would test it exists. And that's this first one, right? This first interaction pattern is saying, okay, we want to be able to create a car, be able to instantiate a car, and it should create a car object for us, right? The cool thing about these interaction patterns is you can do like pull out the code you want there. I just copy pasted that. And then we can do our assertion, assert instance of car. So here we're asserting that our variables holding an object that does indeed belong to the car class. Okay, what would happen right now if I ran this car test? Would my test fail or pass?
You don't have the code file, right? We don't have the.
I do not.
Yeah, so that would be the first problem. Because
right, so this would fail, right?
Exactly.
I think Nico, I think you're saying this would fail because I don't have a car class file, and that's correct. So you always want to make sure your test fails first. Make sure it fails. So this will fail, and then what I'll do is go write the class. We're not going to do that piece today. I would write the class, create the car class with my def initialize, so that this would then pass. Okay. The next thing I'll notice here is it's asking me for this method .make. So I want to make sure def test it has a make. So we'll copy this one here. Okay, and then we know that the make is Toyota. So, and I can see right here that in my interaction pattern, the return value should be a string of Toyota. So that tells me what to make my assertion. So assert that Toyota will be the return value when I call .make. Okay. Now remember, I want this test to fail first. So I'm going to write the test, run it, make sure I don't have any syntax errors, everything's hooked up correctly, make sure it fails, then write the code to make it pass. Okay. Really try to be very disciplined in that pattern in the beginning so that it becomes second nature. Okay.
Can you explain a little more? Yeah. So can you explain a little more why we wanted to fail? I feel like I understand it, but like I would like to hear more of the reason. Like why do we want it to fail first? Okay, would you explain that a little more? Thank you.
Yeah, it's a great question. So maybe I'll answer it in two parts. So first of all, if we run this and it doesn't fail, but it says, oh, syntax error or something, we can catch those really quick right away to know that there's a problem in our syntax in our code rather than an error in our, I'm sorry, let me rephrase that. There's a syntax error in our test rather than like an error or a problem with the code we're testing. The other piece is, what if I didn't test that this failed and I just wrote the code really fast and I saw that it passed, but what if there was a false positive in here and the test in fact could never fail, right? What, maybe it said like card, maybe I accidentally put Toyota in here, right? This would always pass and it'd give me a false positive. So if I run it and it passes, but I haven't yet written the code to make it pass, then I know something's wrong with my test. It's not a good test because it's going to give me back true every single time. Does that make sense?
Yeah, thank you.
Yeah, cool. So always make sure your test can fail. All right. I really wanted to give you guys some time to practice together, but I know we're running short on time. Let's do this instead. Let's do a little like together for 5 minutes. This is I'm going to expand this interaction pattern. Actually, I'm going to create a new interaction pattern down here, and then I'm going to have y'all kind of help me write some of the beginning tests for it. Okay, so this is my new interaction pattern that I want. Whoops, why is this being weird? Maybe because of that caret. There we go. Okay, I do have a student test, so let's go over here. Don't look at it. Okay, I'll give you the first one, okay? So this is what we'll do right now. I'll call on some of you to kind of help me write the test. We'll do this for about 4 minutes or so, as that way you can have a POM before the next class, okay? So the first piece of the interaction pattern expects that we can create a student with one argument and that it will indeed create a student object. So that's where this tested exists comes in. This is a good one to do at the beginning just to make sure everything is hooked up. Now remember, you want this to fail first. So don't even create the student file, student.rb, don't even create that file until after you have this test. Okay. All right, next one. Let's have, who haven't heard from? Nell, do you want to come off mute and help me write the test for this one, my student.name?
Okay. We could say def test has name.
Okay, I like that. Has, and you can feel free to write, it's okay to use like has a name. You can include a and the, as long as it doesn't get too long. Okay, so test has a name.
Okay, so we could say student equals.
Yep, this, I'm just gonna copy for the sake of time.
We could say student.name in the method. Or student, yeah, I guess that would work. Student.name. Would we do assert equal in front of the line, or the line you were just on? Begin with assert equal.
Okay, yep.
Assert equal student name, comma, Bob?
Close, other way around. So Bob is what we want it to be. This is what we're expecting it to be. And then the actual.
Okay.
And actual means like, okay, with the instance then, if I call this method, what will this expression evaluate to? And this is what we're testing it against. So we say we want it to evaluate to Bob. What is the expression I want to do, or the method I want to call to make sure it equals Bob? Yep, this is perfect.
Okay.
Awesome, thank you for that.
Sure.
How about Philip? If you want to come off mute, do you want to help me write the test for student.mod?
Yeah, I'm not sure what mod refers to.
Like you're in mod 1.
Okay.
And then you'll be in mod 2. So it, the mod is like your class.
Okay. Okay. So would you start with student equals student.new or no?
I could start with that.
Yeah.
But what else should I do even before that? Because we don't want it just hanging out in the middle of nowhere.
Oh, define the test name. Yeah. So def tests has a mod.
Sure. Has a mod. Tyler, do you see your hand? So give me just a second. Okay.
And then an assert equal string of 1, comma student.mod.
Yeah, exactly.
Okay.
Perfect. So again, we want to make sure there's a student in instance, and when we call this method .mod, it should just return a string of 1. Okay, and and I'm missing part of this too, right? Because we're not writing the actual code for this, but this this .name method indicates to me, okay, well, it was initialized with a name, so this is probably going to be an instance variable. Well, it will be an instance variable, an attribute, and we're going to want to have an attr reader to, or a method that gives a .name that allows us to read that attribute. Here, this mod of 1, we haven't done anything. So most likely, there's going to be some kind of default mod, where if a mod has not been set, then that student just starts off in mod 1. These are the assumptions I'm making about the code just based off of the test interaction. Tyler, question?
No, I was just actually wanting to do the next one because I am confused and wanted to fail forward, as we were saying.
I love it. I love it. Take some risks, right? It's a safe space to do that. So go ahead. We'll do this last one for the skills.
And quick question on the last one. So the dot mod, that's a method, right? Or should be a
Correct.
method?
Everything that's after the dot is a method. A method is called on an object. So object dot method name.
Right. Okay.
Perfect.
Okay. So define, we're doing this student.skills now?
Yes, please.
And one other question I had first was, can you just explain what the assert instance of does again for me?
Yeah, so this just makes sure that a class called student exists and that this object belongs to the class of student.
Got it, okay.
You could do something like that too here, where you do like assert instance of string for student.name.
Got it, okay.
And this should
great.
also, okay, this is not necessary, but just showing you.
Yes, thank you.
Yeah.
Okay. Def test student has skills. I don't know.
Sure. Yeah, you could do that. I would also too, because I see, I know. I see that it starts empty, right? So I might say something like test skills starts empty, or you can just do test it as it has skills.
Okay.
Okay, great. And then what would we put inside? Instance.
So I would say assert equal, and then put the empty array.
Yes.
Comma student.skills.
Exactly. Okay. And then just to jump forward to this one really quick to show you, because this again is a query method, right? We're just looking at what the skills are. But I can see here this learn method, there's no return value for that. So this is one where we don't care about the return value of the method. What we care about is the side effects. So this is a command method. And you see here, then we care about that this .skills has changed. So we would do something like test, it can add or it can learn skills. Okay. We've already asserted that it starts empty, so we don't need to repeat that assertion. But then we want to actually run our command method. And then because we ran that command method, we want to assert that now our skills does include that skill that the student learned. So student.skills. Okay, so again, this pattern of with the command method to run the command and then do another query method in the assertion to test that it did change. And I saw there's some questions. Tyler, did you have a question?
So I guess
or is your hand
oh, did I never put it down? Sorry.
Okay.
But I guess I'll ask since I have the floor. Does a command method always have one or more extra steps in there, like something you need to call a method and then see if it changed?
Yes, typically.
Okay.
right? And it might change multiple things. Think about that too. So if this learn method changed 3 different things about that object, you'd want to test the side effects on all 3 of those things. Okay, Brett, question? And then Nico, and then we'll wrap up.
I was just wondering on the the name one, since his name in your test is Bob, but in the actual file it's different, whatever.
Yeah.
So would that fail? That test?
No, because, well, I'll say this. So you'll want to actually follow the interaction pattern more precisely, because when we test your like challenges, we're running it against the details that are in the interaction pattern. So you're right, this should be Sophocles and not Bob.
Okay.
Now, this wouldn't fail, like this interaction pattern technically has nothing to do with this other than giving you an example, but for the sake of in Turing, in your challenges, you'll want to keep as close to the interaction pattern as possible. And then, perfect. And then Nico, did you have a question?
Yeah, so my question was, as you were doing after student.skills, empty array, you went, you kind of started combining this test. Before we did like almost like a test for each, like right, until we got to the test you can learn skills, and then you combined dot learn testing dot skills. You added again, and then would you continue and add student promotes after learns the skill? Will this because in the Word or piece I saw it some of this, it seemed like I was doing like one test per method, and you were mentioning that is this a case, for example, where you will just like see something like this, just do one test?
Yep. So you want, each method should have its own test. Okay. That is a generalized, or that's a pattern, a rule to follow. So here I'm testing the dot skills method.
Yes.
Okay. Now here I'm testing the dot learn method, but the dot learn method doesn't have a return value that helps me know whether this method works or not, because the point of the dot learn method is that it changes other attributes about this object. So the only way I can test that this dot learn method works is by running it and then looking again at the skills to make sure that the skills changed.
So oftentimes,
even, well, and I was going to say, even though I'm calling 2 different methods in here, I'm still just testing the dot learn method. But again, in order to test it, what I have to test is the side effects that it had. How did it change my object? Okay. So I'm not going to test any, like I wouldn't go ahead and I wouldn't test dot mod in here again, right? This one has nothing to do with learn.
And I understand. So I mean, on the side note of this, see if I understand correctly, like getters and setters, this will be the method I'm testing is basically a setter, but I need a getter to tell whether it changed.
Correct.
Is that correct?
Yes.
Okay.
Yep.
All right. Thank
Got
you.
it. Yep. All right. Cool. All right. Thank you. All right. We went
Hey,
a
Kat.
little 4 minutes over. Sorry, Mike. Yes, I'm gonna stop recording.